Chris, take it away from here.
Cool. All right. So I titled this here Intro to IPv6. It's maybe a little bit more encompassing than that. So you'll have to bear with my presentation. It does kind of cover a lot of ground. So who here knows anything about IPv6 in any capacity?
I can spell it.
Okay. All right.
Probably came after IPv5.
Okay. All right. Who here is maybe experimented with IPv6? Okay. All right. All right. Has anybody deployed IPv6 anywhere? Nice. Okay.
Vote counts.
Yes.
Oh, that's fine. Anywhere. Yeah. Cool. All right. So I'm just trying to get a feel for the audience this evening. Cool. All right. So let's get started here. Does anybody recognize that number?
It's the number of available addresses.
That's the national debt.
Well, I'll read it. It's 18 quintillion, 446 quadrillion, 744 trillion, 73 billion, 709 million, 551,616. So now, nobody recognizes that number. All right. That is actually a /64 subnet in IPv6. Now, just a quick pause here. That is the amount of IPv6 addresses that I have running to my house right at this moment in time, being routed to my house. Globally unique addresses that I pay exactly $0.00 per year for. Does anybody pay money to get a static IPv4 address? Does anybody or maybe the business to get a static IPv4 address? Okay, so people are paying for those. All right, and you just get maybe the one address. All right, so I got over 18 quintillion addresses that I'm getting for free. So that's a /64 there, that giant number. The whole address space, of course, is 2 to the 128. So you have 128-bit addresses, a lot of public addresses for everyone in every organization. So basically, the concept that we're going for here is no more NAT, or network address translation here, which it was known usually as RFC 1918. So just a quick little run through here. You'll see here we have the /128 here, and then the 1. So that's like your local host loopback adapter there. It kind of scrolls down through. You see I have in the blue. What do we have? The /96 there has got about 4 billion addresses. So that's about the IPv4 address space right there. And you can see it keeps going on a lot farther past then as far as the available addresses. Right there, this /64 we just covered, it's been rounded there, so it doesn't have the 616 at the end. That's the end user LAN. And this /64 is important, and I wanted to highlight that because that'll come up later in the presentation. So, and you can keep seeing, they're rounding there again as well. Here's the regional internet registry assignments there, the /12. I don't even know how many addresses that is. The main concept, though, right now, we're not trying to get too caught up on the address space or the format. I didn't actually give you an address example here. There'll be plenty here in a short moment, though. But basically, there's a lot of other goodies that come with IPv6, and I'm not going to really touch on those tonight, but I want everyone to be clear that there is a lot more. Here we have stateless address auto configuration, which is really nice. That's one we'll cover. The multicast and base specification, we'll touch that briefly. The IPsec in the actual base specification, it's not like an add-on like it is in IPv4. The simplified processing by routers, and there's something else called mobile IPv6, which would be really handy when that starts being prevalent, because it'll allow me to, let's say, maybe move my laptop from one location to another location and still hang on to an address that is routable to no matter where I'm at on the IPv6 internet. So, and that's, I don't know a lot about that. I know that's still in the works, but that would be really interesting to see how that comes into play. But there's a lot of stuff that going on with IPv6. I definitely encourage everyone to really give a good look to the IPv6 article on Wikipedia, as far as like, let's say some homework is, it's really, they got a lot of good stuff on there. So the IPv6 addresses are typically composed of two logical parts. You have the 64-bit subnetwork prefix and a 64-bit host part. Now here's one of the nice things about IPv6. You got changing the prefix announced by a few routers can in principle renumber an entire network, since the host identifiers, meaning the least significant 64 bits of an address, can be independently auto-configured by a host. All right. So basically, right now we have, let's say we have 100 machines, 1,000 machines, 2 machines. If your router is broadcasting, or should I say, advertising a specific, upper prefix, you can just readdress all those machines just by changing what the router is broadcasting. So that's really nice. Let's see. So with IPv6, a single interface is allowed to have several IPv6 addresses at the same time. So that might be a little bit foreign concept for everyone there. Maybe not so much, but basically you're allowed to have, you can have, let's say in theory, 2 or 3 globally unique addresses going to one actual physical interface, which is kind of nice, but also maybe different than what people are used to. So I have there as an example 2 global addresses and a link local address. You're always going to have at least your link local address, which is part of the stateless auto configuration. So here's some examples. I mentioned earlier that 1/128 there, and in this case it's : 1/128. That's your loopback adapter. So everybody is probably familiar with in IPv4 127.0.0.1. That's actually going to be : 1 in IPv6. So you kind of have to free your mind with the address space formats here. You have to move away from what you're used to, because this is the future here. So the link local addresses usually are FE80::/10 as far as the subnet they're on. Those are automatically assigned to each interface based on the MAC address. And then you have your site local scope, and that's supposed to be used for systems that are not connected to the internet. I personally don't recommend that. It was something that previously was called unique local in an RFC several years ago, and then there was some confusion on what's unique and what's local, and so they deprecated that RFC and they created the site local. There's actually a website you can go to that will just has a random number generator and will give you a site local prefix that you can just deploy in your environment if you want. So, and then you could have your router broadcast that prefix. So, mostly you're going to be dealing with the link local and the global unique for the time being. I would stay away from the site local stuff, in my opinion. Other people might have different opinions on that. So here now we're finally getting into what like a globally unique address looks like. Right there, that number that starts with 2001 and ends in 49D2. That's actually, I believe, that's a real IPv6 address that I pulled off of 60.ch is a list of IPv6 capable websites. And that was one of the most current ones at the time when I popped it in there. Here's another one there. And you can see right there, there's the : 53. That's an abbreviated address right there. But the top one in the red is a full-on 128-bit address. So, like I said, it's kind of hard to get used to, but that's you kind of have to stay away from that, because when it comes down to it, you're using DNS most of the time anyways nowadays. So don't worry about the numbers. So it's acceptable and common to abbreviate the longest stretch of zeros in an IPv6 address with 2 consecutive colons. So as you saw right there, there's your 2 colons. So you're going to have 8 or 10 zeros right there where those 2 colons are. Let's take a look here. Let's see what we got. Actually I don't show you the drawn out example here, but we'll get there. So functioning DNS servers are extremely important, if that wasn't already obvious with these ridiculously long addresses. Virtually all DNS servers right now support IPv6, which is kind of nice. I've experimented with Bind9, and that works great. DNS mask is a little bit more restrictive, but it does give you a reverse DNS as well. It's easier to set up on DNS mask, the IPv6 stuff, but then you do run into some problems. If you try to get a really fancy configuration going, and then I put an IIS there, but basically the Windows DNS, that'll do IPv6 as well. So I've only really experimented with it on Windows Server 2008, but I think you can go back maybe to 2003 and it'll do IPv6 as well. Probably not as beautiful as an implementation though. So what do I have here for notes? I have start implementing methods to create unique and memorable host names in your organization. So I mean if you guys aren't already doing that, now's a good time to start working on it. So reverse DNS is now extremely important because you're going to see in some log file or something somewhere, you're going to see some ridiculous 128-bit address, and well, where does that go to? So here's that example that I showed you before. ::53 is the ending address there. That's actually the reverse. That's the full-on drawn-out IPv6.ARPA. That's the reverse DNS for that. So you guys might be used to the in-addr.ARPA. Now it's .ip6.ARPA. So you run your dig-x, and then that's how you would run that to get your actual reverse DNS. And I'll cover that a little bit more in a little while. But you want to make sure that you're not throwing those numbers in there on your own. There's tools to help you out with that. Yes.
Why is it 80::53 and not 8::53? It just strings zeros together.
Wait. Okay. Can you say it one more time? I'm sorry.
I might have missed something, but I thought you said you could replace arbitrary strings of zeros with ::. And you see 80::53.
You're also stripping the leading zeros in any group of four nibbles, and so 80 is the same as 0080. If it were just 8, then it would be 0008.
There you go. So anyways, you can see everything's backwards here because this is our reverse DNS. So this is honestly what I'll use sometimes is there's a package or a program called IPv6 calc, and so this is what I would run right here. This here is what you'd actually run on your terminal or in your shell. IPv6 calc --in IPv6 address or ADDR, and then the actual address, and then you say out revnils.arpa, and then you actually get that's what you would put in your bind file in your DNS server. There's another tool that's handy that will give you this similar output. I'll show you guys that later. But basically look for IPv6 calc. You can install that, like I said, from most package managers. Very basic program. It has a lot more, has other things that it can do besides what I've showed you, but this is the most important thing that I can think of it's for, is because you're never going to get all those zeros right if you're trying to do it on your own. So, stateless and stateful addressing. So, it's basically like, you're talking like static addresses. Everybody's used to static IPs and dynamic IPs with like DHCP. So this is basically like the IPv6 terminology for just like static and dynamic. So the stateless, the /64 subnet is required, which remember was 18 quintillion addresses. That might change at some point in time, but right now that's the you need that if you wanted to use stateless addressing. Addresses are automatically created by RADVD. So RADVD, that's the router advertising daemon. That's a really interesting setup there, and basically that is what broadcasts on your router. If your router has that program running, that'll be where your global unique addresses come from, or your site local addresses come from. It's from RADVD. So, and they're just like the site local addresses, or just like the site local addresses, your addresses are based on the MAC address. So, there is now a way to distribute DNS server addresses via RADVD. Now that's another thing. Basically, a lot of the info you'll see about RADVD is basically saying, oh, well, it's great that I can get an address, but what about DNS? Like, what are you guys asleep at the wheel? Well, there is a way that they're working on to actually give you, so you don't actually have to run a DHCPv6 and still get DNS with the stateless autoconfig. Because the stateless autoconfig is really nice, because like I already covered, you can renumber a whole network for some reason if you need to, just by changing the prefix at your router. You can just change it on one machine and you renumbered all the machines.
When you say distribute DNS server addresses, are you saying distribute something based on whatever the host says, hey, I'm over here, what is my address? Or when you say distribute DNS server addresses, and now you're talking about it, distributing the equivalent of quad A address records, but associating the dynamically assigned name to it, or dynamically assigned IP to it.
Yeah, well, see, that's different then. That's different. Yeah, then you'd probably want DHCPv6. But as far as for hosts that don't need their names, their host names registered in DNS necessarily, there's supposed to be a way to do that now. I have not explored that yet, but I probably will soon.
Essentially, you configure it on your router, and your router advertises it to clients. It's the stateless DHCP. So, anyway, yes.
No,
yes.
that's right.
The clients do an or the router does an advertisement for the network. The clients get their IP address. I figure we'll talk about that.
Yeah.
How that
Yeah.
works.
Well, I'll show you guys some examples here in a little while.
Additional magic ensues to give them the DNS. DHCP, not required.
Yeah. So, I mean, the bottom line is you can have a whole bunch of clients talking, to each other without having a DHCP server in effect. So, and then I've also been reading that RADVD can be configured to allow use of DHCPv6. I'm not sure exactly how that works. To be having both of those going at the same time, I guess it's possible because you can have more than one, IPv6 address. So what do we have here? Client uses link local address to communicate with DHCPv6. All right. So wide DHCPv6 and Dibbler. Those are two implementations that I've come across. I have not experimented with them, but they are something to maybe think about or to look at. Because I haven't really been using the DHCPv6. So yeah, here's moving on. This is like a Windows thing now. You see, we have our router advertisement there in the front at the top left-hand corner. Then there's your Ethernet MAC address. So that's a MAC-derived IPv6 address. Now this is something that Windows does by default. And so you see down below you have your temporary IPv6 address. They have like a random number generator they're using to kind of create like a privacy. Because everything can be linked back to your MAC address, so now that's a privacy issue. So Windows enables that by default. You can actually turn that off because these temporary addresses can kind of cause a problem when you're trying to maybe troubleshoot something. If a number is just changing every hour or 6 hours or something like that, you're like, well, geez, what machine was that couldn't access this or was somewhere where it wasn't supposed to be? So I'm not necessarily saying that you need to turn off the temporary address format or addressing in Windows, but something to think about. This is the command that I usually run, or that I always run. Just the net shell command there, interface IPv6, set privacy state equals disabled. And so then you're just back with your stateless auto config address or your DHCPv6 address.
Now that's done on the Windows box itself.
Yeah.
There's no flag you can set as network
There-
owners
there-
to say you can use this random thing, you have to use MAC address.
Whoa, say that one more time?
There's no flag we can set in the advertising.
It only does that if it doesn't get an advertisement.
Well, I'm saying, you know, the router advertises, here's the client.
It's going to do both. It'll do both by default. It'll get its stateless auto-config address, let's say from RADVD, and then it'll also generate a temporary address as well from its random number generator. The problem is that the number that usually shows up, at least let's say if you're browsing on the web, for example, is going to be the temporary number, unless you run this command. So now, local stuff though, it might actually give you a different number. I just like to play it safe and turn this off. There might be a way to do that in group policy as well, so that you could maybe change every machine all at the same time. I haven't explored that yet. The Linux platform, I've actually been told and read that there's a way to turn it on, but it's not turned on by default. So there's a discrepancy there between how Windows does it by default and how the Linux world does it by default. So, but there is supposedly a privacy option that you can turn off. So now here's back to the some of the stuff that I originally covered, the multicast IPv6. So this works really well on Linux. This gentleman brought up GSlug. I go to GSlug every once in a while. So the last GSlug meeting, I was running some of these because it's a Linux users group meeting, and this can kind of create like a vulnerability issue in some effect. I mean, of course, there's always going to be a circle of trust in some effect if you're on like a somewhat private Ethernet or network. But this will start returning pretty much every host on your link, if you want to call it that has an IPv6 address, and it's accepting echo requests or echo replies. It'll respond to echo replies. And so in a Linux users group, there was an awful lot of replies. And for example, I was able to find some machines in the meeting there that were running SSH just by pulling out an address and trying to connect it with SSH. So something to think about.
Is that radically different than just trying to ping the broadcast address on the network?
Maybe not, but this is how you do it in IPv6.
Yeah.
So I just want people to be aware.
I was wondering if you had actually tried to compare to see if you would get different responses.
I didn't because I was kind of focused on this one aspect at that particular point in time. That would be good. And that's actually an I there, obviously, for interface rather than an L. Just to clarify, that's the font there. So yeah.
I suspect there's a lot of people who may have IPv6 running on their machine and not even know it. Firewall's only configured the firewall v4.
There you go. Well,
My firewall doesn't even pass V6. Are you at a pausing point?
yeah. Let's pause here. I have not heard about that. That'd be cool. The Department of Defense, though, there's actually an article on, if you're familiar with Pingdom, the uptime company, on their blog. There's an article with how many IPv4 addresses the Department of Defense has, and then how many version 6 addresses they have. And they're both staggering. But I think we'll run out of materials to make computers with before we exhaust the IPv6 address space. Let's hope.
So we'll just start running Mars for it.
Wasn't there a push for DoD, from DoD to specify IPv6 our requirement for it, the vendors and whatnot?
There's a federal rule that has come and gone, and all of their cores are supposed to be running. Every federal agency, their core is supposed to be running IPv6 now. I think their deadline was like 2008 or something to have it implemented. Which is probably the only reason why we have it on Cisco and Juniper and everything like that.
That's why none of them have IPv6, because the federal government said we're not going to buy them if they don't have IPv6.
Right.
The unfortunate thing is that we haven't had that same demand drive for vendors to get IPv6 support, matured, well-tested IPv6 support into smaller devices. The stuff you're getting from your ISP to plug into the wall, little wireless devices you're buying at Best Buy. A lot of those things have poor, if any, support. That's the problem we still have to overcome.
Let me give you an example. I just attended like a webinar recently for a storage device, and it was a nice webinar, but there was a little question and answer section at the end. I made a point, since I'm kind of been recently trying to dig into the IPv6 stuff. I made a point to one of my questions to be, hey, when do you guys plan on supporting IPv6 in enterprise production environments? Stutter, stutter, stutter. Oh well, it's on our list of things to do. Well, that's exactly the chicken and egg situation I'm describing. We're working on it, but we're waiting for this or we're waiting for that, or and that's a problem. People need to submit bug reports. If your favorite software, your favorite program or whatever doesn't support IPv6, call it a bug. Submit a bug report. Tell all your friends to do it. That's the only way to get people into action. So I use Zimbra a lot, and there's a whole list of things on there that people are submitting as bugs that are IPv6 related. So
And call your ISP, because your ISP probably doesn't support it, and probably the network engineers probably want to support it, but nobody's going to give them the time until the sufficient customers are demanding they start putting their IPv6 ducks in a row.
My ISP is not even interested in talking to me about it.
Why would Comcast care what customers are demanding?
Comcast's actually on the forefront.
yeah.
With IPv6.
In my particular case, I'm specifically speaking of XO Communications. They were like,
Speakeasy.
yeah, nice.
Quest, any telephone company, DSL, all way out of the loop. None of them had any public plans in place to implement IPv6 in a timely manner.
And yet, shockingly enough, got to give Verizon props, because I plugged this thing into my laptop and I was shocked to see proper IPv6 connectivity. It's tunneled, it's not native, but it's there and it's working and it's already going.
Was it a global unique address? It was tunneled over V4, but it
It
was.
should be, I don't know.
Well, did it start with 2001?
Yeah.
All right. Well, those are common in the U.S. because that's one of our
Yeah,
applications.
so I think it is, but, and then tunneling actually works, and I can go to IPv6.google.com, which is an IPv6 only site, and it works.
Yeah, that was.
I didn't even have to do anything, I just
Yeah.
plugged it in and it went.
That's actually a really funny story, because I covered that in my intro to Linux, or intro to IPv6 specifically to Linux at GSlug. And in my presentation, I'm talking about the shaking Google logo. And now the shaking Google logo doesn't talk. And I happened to give that presentation at the Google office, and I'm just kind of scratching my head like, why doesn't the logo shake anymore? Because it was to let you know that you were connecting over IPv6. Just like if you go to the CAME site, kame.net, the turtle shakes to let you know that you're connected over IPv6. You use the host name, but you're connected over IPv6. And Google used to do the same thing. They used to shake the logo. It doesn't do that anymore. And I'm not sure if that's just because they're getting ready to make it go live, for everybody. But it's still like a walled garden right now. You have to, you can't really get to IPv6.google.com over like some of the transition technologies like Torito. It doesn't really work. Even though I can get to other stuff with that, I can't get to them. So.
If you look at the bottom of the page, I think it says the IP address you're coming from or something. So you can at least verify that.
Yeah, well, it's easy. You
Until
can
there are porn sites that are IPv6 only, there won't be enough push there.
yeah. Well, you can go to the site I mentioned, 60.ch, SIXY.ch, or you can go to the Monowall website. Those will all tell you what your address is running. And I think the IPv6 Act Now site will tell you how you're connected. So here, I just basically wanted to cover. These link local addresses can be handy to kind of start getting you used to IPv6. The only problem is that in Linux you're going to have to add your interface name. So here, %eth0. So that's how you would actually connect. That's a valid command right there with that %sign. Or in this case, the host name. There's a way to specify IPv6 connections in SSH. Supposed to be like a -6. I can't seem to get that to work consistently though. Maybe it's just me. I'm having problems with that. It doesn't seem to work right. I'm not sure if it's a bug or if it's me or what it is. But I didn't put it in there because I can't get it to work right. But yeah, it's kind of a hassle to remember to do that, but it works just fine once you do. So remember that %eth0, because rack your brain trying to figure that one out otherwise. So same thing with, like, let's say PuTTY on Windows. Just put in like a link local IPv6 address. Now, the little note there at the bottom is important. If for some reason that host, if you want to use the host name is in DNS and your DNS server or whatever, whoever's DNS server, but it's got a v4 and a v6 address. You're not. If you put that in there and you don't actually say manually connect over IPv6, it's not going to work. Even though it's obvious that's a v6 address. You might try putting it in brackets. I can't remember if that works right now, but that's how you'll have to do it in a web browser anyways, in brackets. This is obviously PuTTY though. But yeah, that one took me a while to figure out. Because I'm like, why isn't this working? I know it works, but it's not working. So just going onto the connection parameters on PuTTY, and then you can talk over IPv6 no problem. So here's the Windows Server 2008 reverse zone creation wizard. So this is, you know, once again, you got to figure out how exactly, you know, what am I doing here? This is different, and I think I might actually have a picture. So that example right there, it'll, as soon as you paste that or type that into your little wizard, it'll output that right there. And then all you have to do is just put the last 64 bits of whatever host. So let me just see if I got a picture of that real fast here. I think I do. So yeah, here's basically what that would look like. I entered this right here. You can see my cursor, and then it just automatically populates the rest of it for me in Windows Server 2008. This is the R2 edition, but I'm sure Server 2003 or the first release of 2008 would probably do the same thing. So let me close that down. Let's see. Do I have any other good photos or good pictures for you? Here is privacy disabled on a Windows 7 machine. So this is actually a server I'm running out of my house here. So I assigned it basically statically this address, which ends in ::8. So that's a globally unique address here. It doesn't actually tell you in Windows. Whereas in Linux, if you do an ifconfig, it'll say scope global. But that usually, if you see that 2001, which is common in the U.S. here for the IPv6 global addresses, and then this other one here, this is the stateless autoconfig address. But if I, for example, were to browse a website, let's say from this server. This is the address, the : 8 that would show up. This is just there, and that goes back to what I was telling you about how you can have, interface, one actual physical interface connect, or have more than one address at the same time. And then here's the link local address as well. You can see that down there. So, and now, and that's the same thing. They tell you that this is a link local address, but they don't tell you this is a global address. So, that's Windows. And then you can see down here, here's my default gateway. So I just called my router. That's my router right there. I just called the : 5. I've got, 18 quintillion addresses. I just picked 5. Here is my IPv6 DNS server, which is run by Hurricane Electric. It's just like a caching DNS server from them. And then I've got Google's public caching DNS for v4 stuff as well. But yeah, you can see, this machine here does have a v4, address as well. Here's 1.88. So
what's the %11 at the end of the?
That's more Windows stuff. I wish I had a better answer for you, but I don't.
It's enough. That explains a lot.
Yeah, it's more Windows stuff. Sometimes you'll need that, and sometimes you won't. It depends on what you're trying to do. For example, if I was trying to RDP to this machine right now, which I can, I could, from this Windows machine here, I can RDP to that right now because I opened up a port on my firewall for you guys, tonight in case I wanted to show you. I opened a port on my firewall and bam, we're connected. There's no more than that. So let's see. Let's go back to So there's the Windows Server 2008. Yeah, this is another thing. Windows clients, the client OSs like Windows 7, for example, or Windows Vista, they're probably not going to allow echo replies. I said global unique there, maybe on any interface really. They might actually, they'll do the link local addresses.
It blocks them by default.
Yeah, it blocks the global stuff though by default. You have to manually turn that on. So
What about new discovery?
I don't know about that off the top of my head. That's a good question. I'm sorry. I'm still new to IPv6. So yeah, basically, there's a way you can just in the Windows firewall you can just create a custom rule and then say just check ICMP v6 and then just manually select echo, and then you can do that. So let's start moving forward now to the good stuff. How to get your organization or your house, in my example, for one example, onto the global IPv6 internet today. Well, you're going to want a tunnel broker. There's lots of options. Well, not lots, but there's several options out there. I don't want you guys to waste your time. Just go to tunnelbroker.net. Be careful because their site does allow you to connect without HTTPS, and you can start sending passwords around unencrypted there if you're not careful. A lot of their links default to unencrypted stuff. So just be careful with that. Like I say, they're probably the best broker right now. So you're going to want to do that. It's free, just like you can do the certification. And that is exactly how, when you saw this address here, I want you to come back to this for a second. So this is, like I said, a server that I have running at home. This address right here, 2001:470:1F05 A27, all that I got from Tunnel Broker. And like I said, that's one of my 18 quintillion addresses that I pay $0 for, that I have routed to my house. So you can very easily do that for a business as well, if your router or firewall or whatever is IPv6 capable. And you guys could start rocking on the IPv6 internet now. So let's see what else I have here. This is, of course, my opinion, but I feel the best IPv6 firewall implementation right now is monowall. It seems to be the most mature. I don't know. I think it's really easy to use. It's straightforward if you want to set up a tunnel like you've done, because all the ISPs are dragging their feet. And the tunnel that we're referring to is the 6 and 4 tunnel. There's lots of transition protocols out there. There's like Torito and 6 and 4, 4 and 6. There's all sorts of stuff. Your best bet is to just skip all that and just focus on the stuff that I've outlined here. pfSense is based on monowall, and it's a little bit more expansive. Although the last time I experimented with it, pfSense was a little bit harder to get going with IPv6. You had to really kind of dig down and scratch around to get that going. But since it's based off monowall, you should probably be able to figure that out if you're up for the challenge. So now I'm going to just give you guys a little demo here of the monowall IPv6 features with the tunnelbroker.net 6 and 4 tunnel. All right. So we'll come back to this later. This is a required watching. This is a little YouTube video. We'll give you guys for some homework. Let's come over here. And so just as an example here, let's see what we got here. When I turn on this machine here, here's my IPv4 address here. And according to my WHOIS information, that's a nice global IPv4 address. That's great. Here's my link local, see scope link IPv6 address. So remember that FE80 is, anytime you see that, you're talking link local stuff. Now you see this funky thing here, Torito. If anybody's familiar with that, that's enabled by default in Windows 7, and I can't remember if it's enabled by default in Windows Vista, but there's a way to turn it on. Torito is, once again, a transition technology. And you'll see here, I have my link local address on this Torito interface. So this is a virtual interface now. This is my actual physical interface with the cord here. Here is my global unique address here with Torito. Now, and just so you know, it's typically called Torito when you're talking Windows, and you call it Marito if you're in the Linux world. Of course, in the actual ifconfig though, it's called Torito. So the nice thing about what we can do tonight is that since we have an IPv4 address that is globally unique, we can set up a tunnel right now, right here. And I'm probably going to actually do that for you guys real fast. So what I'm going to do is, and like I said, here it says Torito, but it's actually Marito. So I just did a who is here, and you can see that here's our address. So what we're going to do is, so I had this set up. Marito will start up on its own. And so it's confusing because here you have to say Marito, but on your ifconfig it says Torito, because it's just the Linux implementation of a Windows transition technology. It creates it's a big security issue. I mean, you guys might be familiar with it. It creates a tunnel basically through using UDP packets. It's very slow and it works. We could actually use it right now, but it's not as slick as being in an actual proper tunnel. So. Let's.
And it will punch right through your firewall.
And it will punch right through your firewall. Yeah, unless you're specifically stopping it, and even then it might try to make its way through. So let's go ahead and stop that. Okay, so now if we do our ifconfig, we see our Torito interface is now missing. Great. So now let's come back over here. Now you see I've already done this for you guys here. I went to subnetonline.com. This is one that I like to use. And then you have your network tools here. Here's your online ping IPv4. And so I was able to ping the address that I got here in my, I'm not being blocked at all here. So like for example, when I was at the GSlug meeting a couple months ago, we couldn't ping our WAN IPv4 address. If you want to set up an IPv4 tunnel, a 6 and 4 tunnel, you're going to have to be able to work your firewall enough to allow echo replies. Because if you can't, Hurricane Electric basically thinks that you shouldn't be setting up a tunnel. So here's our echo replies for our address here when I submitted that here a little while ago. Using this here, so there it goes. Their IPv6 tools are really handy too. Now this is really handy for your certification. Keep this in mind. This IPv6 ping is really great. The online IPv6 dig is great. It can be these tools right here. They don't have as much on the v6 side, but it's handy, and it's pretty reliable. We're getting a lot of flickering going on here. Sorry, guys. So now let's come over here. Let's go to the tunnelbroker.net site. And so I'll log in here. Okay, and so here's this, now remember you saw before in that photo that I showed you my server at home. Here, this is in bold print here, 1F05 470-827. This is what I have in that photo that I showed you guys earlier. Here it is, 1F05 827. There it is. So this is my tunnel running on my server at home. This is this new stuff down here. They just added this recently, this IPv4 VPN stuff. I haven't messed around with that. I would skip that right now if it was me, and you just want to focus on the important stuff. This is my IPv4 address that Comcast has provided me to my house. It'd be the same as, and this is just a dynamic IP address. It'd be the same as if it was a static address. It doesn't really matter. This is how I would update it here. So, and they're gonna test it to see if it can ping. So, what we're gonna do, so there's that. We're gonna take our testing tunnel here. Now, see, I'm actually using the Fremont endpoint. I'm going back down to near their headquarters. The testing tunnel is using the Seattle endpoint, which used to be a stub, but they've added another connection now from somewhere east. So Seattle is now like, what is the official term? I think multi-homed or whatever. It used to just be a stub from from California. Now it's got multiple connections. So here's our testing tunnel. Let's go ahead and take our address here, and make sure we're on our testing tunnel. Cool. And yeah, so this is 470A. So that was different than we saw before, and that's why they have it in bold print, because it's really easy to get mixed up here. So let's enter in our IPv4 address here. All right, let's enter that in. And so here it is. Please, if you're blocking, there it is. Okay, so we're not, we weren't being blocked on, on the echo replies. So here, has been updated. Please click here to go back to your details. So that's as simple as that was. Now it's got our IPv4 address of this machine here. So what you would do then is basically here, like I use the Linux Net Tools, for example, and we'll say show config. So here, what do we got here? We got Cisco iOS, June OS. Here we go. FreeBSD, OpenBSD. Here's Windows Vista 2008 7. They basically give you. So this is basically right here. This is the config file for. For example, I've set up a machine in Arizona using this right here. We can ping that. We'll be able to ping that machine in Arizona. It's directly connected to the internet. It's not sitting behind a NAT device. This is what I basically pasted into a command prompt on a Windows machine. This is it. We're going to actually use the Linux Net Tools right now. And then basically here what do we got here? So we would just copy this, and then you see I have in here. I just made like a little file. Let's take a look at the quick difference here between these two. There it is. It's exactly the same. It's exactly the same. There's no difference of what I already have in there. Now I could paste these in one at a time manually if I wanted to, or we could just run this shell script here. So let's take a look here. Let's. Was it a little different? Let's take a quick look. Maybe I missed something.
Your IPv6 address is different.
Oh yeah. A1D9. Yeah. Thank you. See, and that's what I'm telling you. You gotta really be careful with this stuff. I'm the guy giving the presentation. I'm sleeping at the wheel. Thanks for catching that, guys. Okay. So there we got that. Okay. Okay, so now you notice we have some new virtual interfaces here. All right, check out what we got. We have an SIT0 and an SIT1. Now, what do we have here? We have 2001 470A1D9. That's perfect. What was in? Whoops. What was in our file here? It was exactly what we see here. A1D9, SIT1. Let's check it out. Sometimes these will say like GIF, depending on which distro and operating system you're on. But so that's it right now. So and this is the slow drawn out version here, gentlemen. You log into once you create an account with Tunnel Broker, and you have a IPv4 address that you can ping and that you're responsible for. You're now on the IPv6 internet that quickly. Now, of course, if we bounce around to somewhere else, well then, so it's not so good on the network computer or on the notebook computers, which is why I have Torito installed on here. Because if I move around somewhere and I want to be able to get to my server over IPv6, I'll still rely on that transition technology a little better. This is also a transition technology, just a little bit less on the transition side, more polished. So let's confirm that the tunnel's working now. So let's do a ping 6. So that's going to be your ping command, or a traceroute 6 for the IPv6 world. So let's try that server I have in Arizona running IPv6. If I can type. Let's check it out. There it goes. So that's how quickly we're doing IPv6 here from right here at the university here. So and then you'll see, because it's using the same tunnel. It's actually, let's take a look at our main page here. So here it is. This is it right here, Revo Mostic 5, and that's using the Los Angeles endpoint, since that's the closest one to Arizona, I think. LAX is what you see there. So we could do a there it goes, and that's how quickly it is, because we're using the same backbone basically. Now we ran the same trace route using that server's version 4 address, and we'd be sitting here for a while. So that's basically it. Now let's take a quick look now. Now that we're talking IPv6, let's take a look at our web browser. Let's go to about config.
Yeah, question.
Yes, sir.
So essentially, you're tunneling onto the IPv6 network. Is that what?
Yeah. This is the 6 and 4. We're sending our IPv6 packets
And you're doing
encapsulated in IPv4
And
packets.
you remap back here to map your addresses here versus at home.
No. My server's still running at home. This is you with a free account, you get 5 tunnels up to. I mean, there's nothing saying that you can't create a second account. Just like with your Gmail account, you could probably have a second one. I'm sure they're going to let you do it. So you can create a second account to maybe get you 10 tunnels. Of course, each one of those 5 tunnels has 18 quintillion addresses available to them. That's the downside. But it does allow you to do RADVD, since you need a /64, which is at 18 quintillion addresses. So right now, if I turned on my RADVD on this notebook here, and you guys all flipped open your computers, you'd all have addresses that quickly. So, at least if your machines were configured to accept stateless autoconfig properly. So now let's just take a quick look here, because sometimes you can get into problems. Like if you got somewhere through this stage here, and if you got somewhere through this stage here, and you might not have actually bookmarked tunnelbroker.net, their IPv4 address, you can get yourself in trouble, because now you've brought on these IPv6 interfaces, but if the IPv6 connectivity wasn't actually there for some reason, like you turned off echo replies or something like that on the tunnel, or on your firewall or something, now your DNS is broken. Why? Why is your DNS broken? Very simple. Your web browser talks to IPv6. So right here it is, network.dns.disable IPv6 false. That's the default. So your web browser is configured to do these right here. This is what your web browser does. If as soon as your machine thinks it has a globally unique IPv6 address available to it, your web browser is going to start talking IPv6. So we should be able to get a shaking turtle now. So we can go to and there's our shaking turtle. And then we'd also be able to get to IPv6.google.com as well, but we won't get a shaking Google logo. So, I mean, it's kind of one of those things where people have a hard time with it, because it's nifty, but it's you're still seeing the same stuff, when it comes to, like, let's say websites and whatnot. But it from the sysadmin perspective, there's a lot of beauty there. So
the security issues do keep setting off red flags in my head. And as we looked, we flashed that screen that you just saw there. It said that most of the code from Kami.net had been merged into FreeBSD and NetBSD, and I saw OpenBSD isn't there. Is that just because I don't like the way Theo is cursing, or has there been discussion on the OpenBSD list that this is?
I don't have the answer to that. I really don't. I imagine that. I wouldn't be surprised if they don't list OpenBSD there, because maybe the OpenBSD guys didn't give them permission to list them there. I mean,
And if it were merged, they'd list it.
I really don't know. I mean, it's a good question, but
It's such an insular community.
yeah, it is, and it's a really good question. But I mean, at the end of the day, that's totally off where we're trying to be. I mean, whose code gets implemented where isn't the issue. The issue is making the internet a place where computers can talk to each other again without being restricted. So
Well, that is opposite a security issue, though. You're talking about everybody's suddenly got their own address. We all flip open our computers and we talk from you on whatever.
RadVD, yeah.
Yeah, okay, fine. And it turns out that you're actually a bad guy sniffing the screens. This plug and play kind of thing is obviously vulnerable.
How is this different from IPv4 from a security perspective?
I mean, if I'm running a DHCP-v4 server here right now, and you guys flip your machines on, I mean,
And there are
you have to understand that there's always going to be security issues. People use NAT as like some like safety net, and that's not what it was designed for. It was designed to limp along IPv4.
Yeah,
So
it works.
it works, but
As a security measure? It
Yeah.
works?
Yeah.
Absolutely not.
It does a good job of projecting inbound traffic that you didn't solicit.
yeah, go ahead.
But we're also not in the right place to have that discussion.
Well, the main. I don't want to get too far off topic here. The reason why I'm here tonight is because other people in other rooms have decided that this is the way the internet needs to go, and so we can try and stall and drag our feet. But the bottom line is that the decisions have already been made. We can sit here and go back and forth about is IPv4 this or IPv6 that, so we're blue in the face. But the bottom line is that these are the tools that we've been given to implement right now, and it's just a matter of time when we're going to either be forced to or we're going to have to be replaced. And that's really what it comes down to.
If you are concerned about security, then you should definitely migrate to IPv6 because you are required to implement IPsec under IPv6.
Yeah, IPsec is actually. I mean, we're obviously not really using that right now, but it is part of the base specification, like I mentioned initially.
Yeah, it's required.
So anyways, if you lock yourself out somewhere for some reason, your IPv6, you forget to turn down your tunnel here and you move your computer to somewhere else, you can just, and you're doing something web-based, you can just turn this to true, and then you start talking IPv4 only then. But either way, I mean, that's basically it. I want to give you guys, so now we're connecting here using the v6 address. Now, I don't actually have to use, you see the 2001, this is my firewall here. I don't actually have to use that now. I just did that for, showcase purposes. I could just use the host name, because the host name is in DNS, again, IPv6 and IPv4. I actually, yeah. So anyways, so here's the version 4, and then here's the version 6. So anyways, so I mentioned before that I opened up. So here's the IPv6 packets here. So we should be able to ping that, or sorry, the ICMP packets. Here's the ICMP packets for the firewall itself. And then I just implemented some various stuff here. I mean, here's the RDP here, straight to that machine. If I can turn that off as quickly as I can turn it on. But I mean, basically, let's go into our general setup. Actually, we're gonna have to go to advanced. Let's go to our advanced setup here. So this is the most recent version of Monowall. So you have to turn on the IPv6 support and then save to get that going. Then let's go down to our interfaces. Whoops.
Now where's Monowall running?
This is running at my house.
On a device or on
This
a
is running on an old Dell like Pentium 3 that I salvaged from a friend's basement.
running,
Monowall.
yeah, but is monowall a,
It's an actual firewall OS. It's based off FreeBSD. It's really nice because with monowall, if I want to go from, let's say that Pentium 3 dies on me because it's like 90 degrees in my house right now, well, that's okay because I have this. All this is backed up in an XML file. All I got to do is just turn on another server, install monowall, upload this XML file, and it's like nothing ever changed. You know, the MAC addresses might change, but I can always spoof those here. So monowall is really nice. It's PHP and XML. It's one of the, I think, the first or maybe only operating systems that does such a thing. Either way, so here's the IPv6 mode. So this is now we're running RADVDs here. I have 18 quintillion addresses plus whatever come into my house, and let's say I have a few 100,000 machines. All right, they're all going to get addresses from this guy right here, just like if I was running it on this machine here, this notebook that we have here for the presentation. So we said tunnel, and then tunnel basically that means 6 in 4, which is what we're doing. And then here's the address I gave it, and that came right from my tunnel details page, which is this guy right here. So I basically took, what did I take? This guy here, client IPv6 address, right there, ::2/64. Let's go over here. And there it is, ::2, and then here's the /64, which you need for RADVD. And this is my my WAN interface here. So what we're working on. And then here's my IPv6 tunnel endpoint, which you get from your tunnel details page right here. Here it is. Server IPv4 address. It's just plug and play basically.
So your ISP does your ISP support IPv6 natively?
Comcast started doing trials. You had to request to be like a beta tester basically. And I didn't request because this works so well. I didn't even bother to request because they're doing it in various stages. Eventually,
Just as a data point, I've requested. They said we're getting ready to do trials. And that's as far as they've gone.
Yeah, yeah. I never bothered because this is handy for me.
did you fill out the survey?
What's that?
Did you fill out the survey?
Yeah. And then that's
So, anyways, let me give it a screen real estate here. So, anyways, that's as simple as it is. You put in your tunnel address here. Here's the ::2 in this case for me. My client IPv6 address. They even give you little helpers here. Then you put in, and then what they call server IPv4 address, and then you're good to go. Then you save your config file. Then you jump over to your LAN interface, and this is where the fun part comes in. And this is where some people believe in security through obscurity and whatnot, but I just picked ::5 because everybody does 1 in IPv4 a lot of times. So I said, let's call it 5. That was my decision. And if it has to be a /64 for router advertisements to work. And then here it is, right here, send IPv6 router advertisements. If this option is checked, other hosts on this interface will be able to automatically configure their IPv6 address based on the prefix and gateway information that the firewall provides to them. So there you go. And then there's also DHCPv6 right here where it says manage address configuration. I don't have that turned on, but I could. I could turn that on right here. So you can have them both turned on. But I'm usually manually entering in my DNS and stuff like that, so it works just fine. But you can see right here, here is a machine that gets its address through stateless autoconfig. Let's take a look at down here, this guy right here. This is a machine here running Ubuntu, and we should be able to. This is just flying right through the router. There it is. That's flying right through the router that we're connected to right now through the browser, the firewall right here. That's that machine right there, and that was for SSH. Hope you guys don't try connecting to my machine. And somewhere in here is the ICMPv6 for that machine. Here it is. Oh, that's RAD6. Let's see. Well, one of these in here is my ICMP for that machine, and I can just turn that off or turn that on arbitrarily. You can do all sorts of fancy stuff, but the bottom line is that there's no more NAT. You don't have to, I mean, I can hide those machines or I don't have to. It's all my decision on this router here, on this firewall.
So that opens up port 22 to anybody in the world.
No. Yeah, oh yeah, because that's the way I have it configured. Let's take a look. Let's take a look at that machine real
Instead of
fast.
NAT rule forwarding, doing the port.
Yeah, no, there's no port forwarding.
This is it's similar to just an access list allowing
Yeah,
that traffic.
here it is. I decided to say source address, any. Now if I wanted to, I could just punch in my IPv6 address right here in the firewall. But right now, I'm allowing anybody, because I might connect from anywhere if I'm using, let's say, Torito, for example. So I could say single host or alias, and then just punch that in, or network. But there's no more port forwarding, so I don't have to decide, well, which machine am I going to forward SSH to on port 22, and which one's going to be like a different port, and which one's going to be that. There's no more guessing games anymore. You can just use standard ports, and everything's beautiful, and that's the way the internet's supposed to be. So, as for how painless this is with a OS like MonoWall, it's kind of silly not to be running IPv6 when you can. So, and considering that you can get quintillions of addresses for free from these guys here. Now, here's a certification here. Let me just show you real fast what this.
Besides running IPv6 because you can, is there any other
Well,
reason to do it right now?
Yeah, for exactly what we just talked about. I mean, you can eliminate things like VPNs. You can eliminate things like port forwarding on non-standard ports, services that you want. You can now run multiple web servers. I mean, I asked you guys who is paying for an IPv4 address from their ISP. A couple people raised their hands. There's a lot of organizations out there that are paying for, static IPs from their and we're running out of IPv4 addresses, which is why they're charging for them. So.
There's a charge extra for IP6. Scroll down a little bit, look at the IPv4 exhaustion you have to up on the right side.
Oh yeah, that's great. Yeah, and actually at my April presentation at GSlug, I think that was somewhere about 400 days or something like that, 405. I mean, Now the V6 glue, my domain registrar for my domains is GoDaddy. So GoDaddy allows version 6 glue, so you can actually have their name servers allow that. For example, like who's one that I've recently come across, Dotster, for example. There's one that doesn't allow version 6 glue. They actually don't even, I mean, there's a lot of that's part of the chicken and egg situation. There is domain name registers that you can only do so much. For example, who I'm using for my name servers right now, they're called ZoneEdit. They're great because they allow you to do version 6 addresses, but they do not have version 6 name servers. So I can't run native right now using ZoneEdit. And that's where Hurricane Electric comes in. They have a beta trial right now for DNS. And I just started messing around with it. But you can use theirs. I was having to run my own name server if I wanted to get like full-on reverse DNS. I can do forward DNS with ZoneEdit because they allow quad A records, but they don't allow pointer records with IPv6. So this is something to look at too. Like I said, it was in beta mode before. I don't know if it's still in beta. The open beta has been expanded. So, but this is something to look at. And then you can use your same account that you create to actually make your tunnel. You can use the same thing here. And then here's the certification. Oops, here we go. And then there's something else I want to show you guys in a minute as well, why it's on my mind. Let me see here.
Another reason to be thinking with this IPv6 stuff, so when in 2 years, it's actually really important for every network to be talking IPv6. You'll actually already know how to do it.
Yeah.
Because in 2 years, sites are going to start showing up that don't have IPv4 addresses. There's no IPv4 address to give them.
Even worse.
That's where that 400 days comes from.
So basically the Mayans were right. The world ended.
Yeah, no, it's going to be rough. There's going to be a period of time where everybody's a little, off kilter and whatnot. But the sooner individuals like yourselves get on, on the right track, you can start putting end users at ease. Because like I said in the beginning of the presentation, don't get too caught up on the address space, or the format. Just do it. This is it right here. I mean, this is as complicated as it has to be. You set up a tunnel for, in this case, because our ISPs aren't giving us native connectivity. But you set up a tunnel, and now you're talking IPv6. So, and you know how to turn off IPv6 in your browser. If for some reason somebody turns on IPv6, it puts in a DNS entry, but their server doesn't talk that. Then you get into problems. So, what's your question?
So what's going to happen with IPv4 only devices when the rest of the world is IPv6?
Well, that's why the
Throw them
video.
away, just like we throw away our thumbs.
The video that is going to be your homework to watch. The video actually kind of has a nice. It's kind of a rhyme. And what does he say? He says, my trace routes are all showing stars. My packets would move faster in cars. So that's probably what you're going to have to do with your IPv4 stuff.
Do you know, are any of the sort of homebrew router OSs supporting IPv6 yet?
That's it right here, monowall.
Monowall
and
will run on like
and actually there are some builds of DDWRT, if anybody's familiar with that. There's a build called CrushHat that I've experimented with on a Linksys WRT54GL, and the CrushHat build, it's from like 2008, but it does IPv6 just fine. There's some other bugs that I found in there.
The Cisco routers do really well too.
Well, there you go.
I think the airport extreme, it also support V6.
Yeah.
A lot of Apple's recent hardware for the past 2
Oh, yeah.
or so years all supports, has good support for IPv6.
Yeah, I think the airport extreme stuff that all does it. So, anyways, here's the certification process. Basically, you take the newbie test, and you just go through all these various things here. They start getting hard when you start having to do reverse DNS and whatnot. So, and as you can see, I'm kind of behind in my daily trace routes here. That's all optional stuff. And the daily digs, you just submit in the dig and trace route who is output, and then you get more points. But once you get to like this area here, you're pretty much there. Once you know how to run a dig, you know how to do it. And then they're supposedly sending out T-shirts. I got an email saying they were going to send out T-shirts to the Sages, like I don't know, about a month or so ago. I haven't gotten a T-shirt yet though.
The T-shirts have pockets. Because without that,
there you go. So let me show you something else real quick that I wanted to show you as my secret weapon for passing the certification without losing your mind. Now, just so you know, because I did lose my mind, I actually had to cheat. I was having problems with bind and reverse DNS. So what I did was I had to put my whole process on hold for a little while the DNS was updating to a server that I had running DNS mask. Because DNS mask does reverse DNS a little simpler than bind, but then you run into other problems then as well. So then once I passed the professional test, I think is what it is. Is that reverse DNS? One of these is professional. Reverse DNS. Once I passed that, I went back to bind. But there's a way now where you can do it straight in bind now if you want to, without killing yourself. Or let's say Windows Server 2008, like I showed you before. So this here, we would just put in our allocation. So let's go to our main page, and we're in the certification. We need to be at the main tunnel broker page. So here we go. Let's say monowall. So here it is. So here's our allocation. So here we have the : 2. We're going to remove that. This is CaptainGeek.net. He's got this. This is the only zone builder I found on the internet that works properly. There's other ones that I found, but this one's really handy. And then all you got to do is just punch in your stuff here, punch in your name servers, and then you'll get a nice zone file for reverse DNS. And it's pretty much copy paste, plug and play. And that I found is a really handy tool, because the numbers and whatnot and the reverse nibbles can be a problem. So let's maybe let's maybe go ask any more questions. I mean,
I have one question, it's also kind of really minor detail, but do you know, does the tunnel broker or Hurricane Electric, do either of them support a MDNS client updating? So if you have a DHCP address from your ISP, that you can get, you know, have them automatically, because like I know a lot of, you know, that's how I have I have DNS to my home router.
okay.
And my router is an MDNS client. So
Well,
whenever my ISP decides it gets a hair up its butt and change my IP address, then it automatically just updates MDNS, and so my
So you have like you have a dynamic IPv4 address is what you're saying.
Yeah.
So you're talking about like dynamic, like a automated dynamic updater.
yeah.
Okay. There's a way to do that. Actually, I read about. I haven't explored it because my IPv6 or my IPv4 address with Comcast changes so infrequently that whoops, it's broken. You know, like
What kind of-
it's been like a year.
What kind of account do you have, just normal?
I just have a
personal or-
normal residential account. I used to have a business account because I needed the bandwidth before, but then once they bumped the residential accounts up to enough, you know, I stopped doing that. But yeah, I mean, I'm running full on web servers and everything off my residential account. It's just fine. You know, my mail server is down right now. I actually have a hardware failure, so like I'm just now starting to get stuff back up. My motherboard died in my main server, so it's kind of a big mess. I don't have everything running yet. So, you know, this is great right before a presentation, but either way, yeah, right in Seattle. So this is basically, you know, this is as simple or as difficult as it really needs to be. Like I said, I recommend using these guys for the time being, but don't still bug your ISP. Bug your ISP about IPv6, because if everybody just keeps using Tunnel Broker, that's not really fixing the problem, because that's still a transition technology. So, but if you want to start using it now, if you want to start playing with it, this is a good way to go. And yes, you saw I have a lot of rules in my firewall here for various services and things that I might want to access from the internet. And the one thing that are we still sending pings? No, okay. The one thing that you'll notice, so like using let's say like Torito, for example, you can install that from a package manager, or Merito, sorry, from a package manager on Linux as well. You'll notice like initial pings the initial echo reply will take a long time. It'll be 1,000 milliseconds or 800 milliseconds, and then they'll level off and be something reasonable. That's just part of the whole thing. It's UDP packets going, fighting their way through your IPv4 router or firewall, and at least with this method here, actually setting up a proper tunnel, any new machine that comes onto my network is just automatically gets an address, so they're not getting registered in DNS, but that's okay for me right now. I'm just taking it a step at a time, and I think if everyone else takes it a step at a time, we'll all be heading in the right direction. So feel free to send me an email if you guys have any problems. I got my email in here somewhere. It's just my first name, or my first initial of my last name, @gmail.com. So any more questions or any thoughts?
So it used to be when you wanted a Class C space, you had to basically ask some service, whether it was their backup provider, whatever, they would have to log in something. Where does Hurricane Electric get their address space? And does it go through a similar process?
Well, here you go. These addresses here are, they're the real deal here.
Right. But they got their addresses from ARM.
Yeah, they got them from ARM. That's exactly it. Here it is, Hurricane.
You can either ask ARM for your own addresses, and if you sneeze in their general direction, they'll happily give you a /48, no questions asked. If you want more than that, you have to go through all the justification hoopla. However, your ISP, if your ISP is IPv6, well, it should be able to throw a /48 at you without any problems.
And if your ISP isn't, well,
Then you need
you're
tunnel.
screwed out.
Yeah, eventually, basically, like even like your cable boxes and stuff like that. I mean, it's sad that we still have to have cable boxes, but you know, eventually your light switches and pretty much everything will have a V6 address, which is where that stateless autoconfig comes in really handy. Because a lot of devices that'll talk IPv6 don't necessarily need DNS and whatnot.
That's one of the big reasons why Comcast is so interested, that they have more cable boxes than IPv4 customers.
Exactly. Exactly.
So they want to be able to talk to them.
Yeah. So that's it.
Yes, direct assignments.
We're supposed to leave in 15 minutes. I want to grab some leftovers so if anybody wants to compete with me.
There are so many leftovers, I don't think you'll have much competition.
What was that video that you?
Oh, the video. Let me show you that video. Here, I guess the link is where. Yeah, I should mail that out. Here it is. It's actually kind of entertaining. It's actually at it's at a RIPE NCC meeting. It's from a couple years ago. This guy playing the piano. It's really cool. He kind of like says goodbye to IPv4 in a kind of a funny way. So it's kind of interesting. That's where I got all my trace routes are showing stars.
We have a few, yes.